Good afternoon, everyone, or morning, or whatever it is. Welcome to the One Deeper podcast. Today, I have for you Dr. Peter Spronck, Professor of Computer Science and AI at Tilburg University. We have an awesome conversation. It's all to do with AI, so if you don't care about AI at all, you should probably stop listening now. It's great. My audio is a little messed up for the first minute or two, but it sorts itself out. So just bear with me. Other than that, please enjoy this conversation with Dr. Spronk. It was awesome. I really enjoyed it. Thanks again for listening. Dr. Spronk.
Good afternoon.
Welcome to the show. Thanks for taking the time. I know it's like a Friday evening, but like you probably have better things to do right now. But this is cool. I appreciate you taking the time. Um, anyway, so you want to just introduce yourself to people who are listening?
Sure. My name is Pieter Spronck. I'm a professor of computer science at Tilburg University. I am associated with a department that's called Cognitive Science and Artificial Intelligence. In this department, we research cognitive science and artificial intelligence. That's logical, and we also teach programs on those topics. My personal main interest is in artificial intelligence in computer games, which sounds maybe a little bit frivolous, but the idea of a game is that it can be anything that is a virtual environment, and the advantage of doing research with a game is that it is a safe environment because you cannot destroy anything. It's all in a virtual environment, and it allows experimentation. So you can try out different kind of things. And mostly, if I talk about artificial intelligence in computer games, I'm mostly interested in behavior of virtual characters, but we also do research in other aspects like having in a game world where a human interacts with the game world, trying to learn things about a human, for instance, by using sensor technology or by just observing the kind of things that they do in a game world.
Nice. Okay, so actually, I wanted to talk to you about this. I want to talk to you about video games in particular, but like, because because
Well, it's one of my favorite topics,
yeah,
but I, but I do also research in other kinds of games.
yeah, yeah,
So
yeah.
we also do research in board games and in role playing games and uh, puzzles, and so lots of different kind of things that you can do research in, and which I enjoy engaging with. So
I
go
mean, I
ahead.
mean, AI has a long history with games, right? Like, I feel like that was the first sort of space that AI was trying to be like put to use in.
I'm not sure that is actually true, but it is true that when the term artificial intelligence was first coined, which was in 1956. Well, maybe some people used it before that, but in 1956 it became a topic of science where a group of researchers came together in Dartmouth for a couple of weeks, and they wanted to know uh, to what extent a computer can reach a human level kind of intelligence, and this is fairly early. And what they also did is they talked about kind of problems that you can use to test whether a human has reached, whether a computer has reached that human-like intelligence. And one of the problems that they talked about is playing chess. Because at the time, the idea was chess is a game that requires ingenuity, tactical insight. You must understand the game. You cannot just do it by calculations because it's far too complex. So, if you can get a computer to play chess at the level of a grandmaster, then you have achieved a big step in artificial intelligence research and bringing artificial intelligence to the level of human intelligence. Now, of course, it took until 1997 before we actually had a computer that could play chess at a grandmaster level. That was Deep Blue that IBM created. Long before that time, people already realized that you can play chess without any human level intelligence at all. You can do it with calculations. Of course, you have to be smart about it, and it's not purely calculations. You have to build in certain strategies in the evaluations of the boards, but actual human level intelligence is not needed for chess.
Hmm.
But of course, by that time, other problems came up, and games are. So, one reason that games are often used, and now we're talking about games which are challenges where you have a winner and a loser, for instance. So, not games that are purely to entertain you. That's another other branch that you could be interested in. But one reason that games are used for this kind of research is that you can run competitions. So if I have an AI for to play, no, maybe not chess, but another game, a more complex game, a game Go. Well, that has been done now already. But there are other games like Arima, which is a typical game which is incredibly hard to play for computers. And I make an AI that plays Arima, and someone else makes an AI that plays Arima. Then we can see who has the best AI. So who
Right.
has advanced the AI the most. Again, a completely safe environment. We run these competitions, and such competitions have been run for chess, yearly competitions for chess computers, and that's still being done, and other games as well. Chess is probably one of the best known ones where this is done, but it's definitely not the only one.
Do you think like if we went back, say, a couple hundred years, and we showed and people saw what, for example, AlphaGo can do, or with Dota and stuff, do you think they would think that okay, we've solved intelligence, or do you think that they'd be like, no, because right now there's this thing is like whenever we solve something, it's like, oh, that's not real intelligence anymore. Then
Well, it is a hard question because it probably depends on the person. But a typical example is the mechanical Turk,
right,
which is for if people are listening and don't know the mechanical Turk, that was a robot chess player, and I don't know the date. You can probably look it up, 1850, something like that,
yeah.
probably. Which traveled around the country to fairs, and people saw this robot playing chess, and it was a chess table with it was a table with a chessboard on it, and the robot was just the upper part of a human, and it moved and moved pieces on the board, and it played a very strong game of chess.
Oh, really?
Of
Yeah.
course,
Like he played a strong game. I didn't know it was like I didn't know he played a good game. That's interesting.
yeah, because there was a very good human chess player hidden under the table
Oh,
who
right,
moved
right. Okay, yeah, sorry. Yeah.
who
Right,
moved the robot,
right, right, right.
and that is how this worked. So it was not a real robot, but
Yeah.
it and people were amazed that the machine could do this. And I assumed that people would think that this is a machine that imitates
All right.
humans and has a sort of human level intelligence. But that would be partly based because it can play chess, but also partly because it looks a bit human like. So that is people often ascribe more intelligence to something that or more human like intelligence if it looks like a human.
Right. Like okay, so I've been thinking about sort of like I- so you don't go to like so do you go to work every day and think okay I want to solve general intelligence or like what's the like I don't think I don't think almost anyone does that, right? Like they don't go into work thinking, I mean, except maybe like a deep mind or something, I don't know, because like but
No, definitely they don't do that. I don't think anybody thinks today I'm going to start working on a project for general intelligence, and then in 5 years we have reached general artificial intelligence or artificial general intelligence, which is usually called. And that means in an artificial intelligence that can do anything. You just have to tell it the task, and it can do the task for you. I don't think anybody thinks that is in any way achievable well during our lifetimes. Maybe it will never be achievable. So people are always looking for tasks that you can solve.
yeah, I mean,
And
even human beings can't do that, right? Like even like if you take if you just like grab a random person off the street and say, "Hey, do this thing," they'd be like, "What? I have no idea what." Like, you know,
yeah, but you can explain it. You can explain it.
you can
And
explain it.
of course, you would expect it if you have an artificial intelligence, an artificial general intelligence, that it could do anything that you explain to it probably better than a human can do it because humans have lots of limitations and an artificial general intelligence there are limitations, but you can put these much further away than our own limitations are. But what I want to say is that you said maybe the people of DeepMind are working on artificial general intelligence, and I don't think they are because they know their own technology far too well, and they invest a lot in deep learning, and they've done lots of impressive things with deep learning technology. Um, and then AlphaGo was just a first step there, or maybe the second step. But they did lots of interesting things after that. AlphaFold is one that is fairly recent, which is incredibly impressive. Which is not just playing a game; this is actually helping people develop new medicine,
Right.
which is an incredible achievement, which people have been working on for a long time, and they now achieved something there, and they made what they did available for free. So this is also very beneficial for the world. But that is what they work on. So we have this particular problem for AlphaFold that was uh, protein folding, and now they did this in a really good way. With a high accuracy of detecting the particular structure of the molecules that they're researching. And from there on, they can continue, maybe improve this or go on to other tasks, but it's always limited tasks. So we have but because you know that you can work on a task and then try to create a good solution for that task. But artificial general intelligence is not a task. It is a whole it is a concept. And then maybe the people from OpenAI think that they are working on that. And you could actually argue that they're working on that. But the way they're working on it, as far as I see it at least, is that they try to make a more general structure, which you can use then to do particular tasks, such as uh, making translations,
Right.
creating new text, but also maybe do some image creation based on text. Alpha OpenAI is mostly working on linguistics, but it can be applied in many different domains.
Right. So I was thinking about, so like, okay, so let, let, let's think about some of the most impactful, let's say, inventions or discoveries, right? Like things that have, like, okay, let's just take it like the example that I'm recently most familiar with is, let's say, the Fourier transform, right?
Yeah.
Okay, used everywhere, used for all sorts of things, incredible discovery, right? Okay, but if we have to keep waiting around for people like Fourier to show up or like Einstein to show up,
Yeah.
or that's not a it's not a scalable solution, right? Like it's pretty hit or miss. But so
Hmm.
but so like there's real value. I mean, if you could have a, I think, do you think like just general intelligence might not be that useful, but like a
Well,
super
it
intelligence,
probably is very useful, but we cannot create it.
yeah. But like we wouldn't be like so that there are two sides to this, right? Like
Mm-hmm.
on one side people are like terrified about this, about like a intelligence explosion or whatever, right? If it happens, whatever. But there are like problems that we would love to have solved, right? That we just can't see, that we're not,
Mm-hmm.
we don't seem smart enough to know how to solve, right?
Mm-hmm.
Like one example is like that I think about is like, I think so. Imagine the fact that we have to grow an entire animal, right?
Mm-hmm.
To harvest the stuff that you want. Like,
Mm-hmm.
but why can't we just go straight to the end product, right? But apparently, it that's an incredibly difficult problem. Like, just to synthesize the actual proteins and the meat and make it scalable and environment and economically
Yep.
feasible, right?
But people are working on that.
Yeah, yeah, they're working on that. But like, wouldn't it be nice if we had like a super intelligence to be like, hey, can you help us figure this out? you know?
Yeah. So what I think here is the following. Uh, um, you can imagine that you would have an artificial intelligence that you can ask a question, and maybe the artificial intelligence knows a lot about a particular topic, like medicine. And you can ask it a question. So, can you solve this? But that's actually what we try to do. We just said we have this limited domain, and the medicine, of course, is not limited. But let's say we have a cancer medicine for particular kinds of cancer, and we have lots of data. We have X-ray pictures, we have patient histories, including the medicine that these patients received. Uh, we have anecdotal evidence of particular things. And if we feed that all of that data to a computer, that is so much data that humans cannot grasp it anymore. But then we can ask the computer to make suggestions. Then we can say, look, what kind of combination of particular drugs would work best, would give probably a good chance to deal with this kind of cancer. And then, well, by examining all that data, the computer could cough up an answer. But it's not as if the computer now becomes inventive in the sense that it thinks of something completely new. It's applying the algorithms that we put in the computer to sift through the data, combine things, find patterns, and then give those patterns back to us.
Right. So the bottleneck. So the assumption here is that in the data that we can feasibly like, so first of all, we collect data that we think is important, right?
Yeah.
That's already like we already we might be missing things that are truly important. We have no idea, right? And then we are assuming that in that limited domain of data that we've collected, that there's enough information that can be recombined in a meaningful way to generate a new insight, right? But if you take the example of Fourier again, right? It's not like
Mhm.
he had, I don't know, like that, that's insight, right? Like it's not like he had a massive training set of all the math that's ever been like, and I mean, maybe he did. I don't know how smart that guy was. but like the implicit idea is that what we need to discover is already in the data that we've collected, right?
Yeah.
That seems problematic.
Um, there are many ways to get information out of data. And a simple way of doing that is, for instance, finding correlations. That is the traditional way. You just look at, well, we have a couple of variables and they're in there. And when we just analyze all these variables, we suddenly see, okay, when this variable gets higher, that one usually also gets higher. So maybe they have some kind of connection. Or maybe if this one goes up, that one tends to go down. So there may be a connection there. And then we can go a bit further and say, no, no, it's not really one variable linked to another, but there's combinations of variables. And you can go even further with certain technologies like genetic programming. You can create formulas, and it can create general formulas that find patterns in data.
Mm.
But it's always, well, virtually always, it's pattern detection. So we find patterns in data that we didn't know before. And if you can, and that is not even that hard, if you can create an algorithm that has knowledge of these patterns we already know, and this is all the data, and I'm going to look for patterns in that data, and that shouldn't be already known to us. So you can probably create something like that, and those things I assume already exist. And then so you can get new information out of there. Now, what I'm not that familiar with Fourier transformations.
It's just an example that I use because like it's like
Sure,
as
but
an insight.
there's a certain theory behind that, and I can imagine that if you ask the right questions to the computer, say, well, you provide it with the right data, and you say, can we find a generalized method to turn certain functions into other functions, which are then much easier to deal with. And so that is a very vague question. But if you have the problem, if you know, okay, actually, this is my problem, I need something to deal with these kind of functions, and a way to do it could be to make a transformation to other kinds of functions of this sort. If you can make that a fairly specific question, I can imagine that you can generally create an AI that does that for you if you can provide it with enough data. And the data could be data that comes from calculations.
Right. Okay. So I mean, I was just thinking, like, intelligence is really valuable, right? Like, you know
Yeah.
what like
Yeah, you can argue it's the only valuable thing that we have.
yeah, like think about how much money we spend on like for example, the evidence suggests that it's real. So so it's really hard to make someone more intelligent, but it's easy to make someone less like it's easy to make someone who's intelligent dumber, like look dumber by like the poor nutrition when they're growing up, yeah, all this other stuff.
Oh, in that
Yeah,
way. Yes,
yeah,
yes, yes.
in that way,
Yeah.
right? So like you can limit the thing, but wouldn't it be great if we had like an if all we did by creating some AGI is to get it to answer how to make humans more intelligent? That would might be totally worth it, right?
Yeah, you already answered part of that because you said feed them well. That is one thing, and
Yeah,
give
for
them good
sure.
education.
Yeah.
And but I have another thing here, which I have been I'm close to 60 years old now. So I'm 2/3 to 3/4 done with my life. I think I've built up so much in my life, and as soon as I die, that's all gone, except maybe what I write down.
Mhm.
And even that, because I write down stuff about computer science, after 5 years that is outdated, so it's not any use to anybody anymore. And I could probably have produced much more. And I'm probably not the greatest scientist that is there, but other people would be much more valuable to say. But everybody runs into that area where they die, and then they're gone. And then you say, well, we have to wait for a new Einstein and a new Newton, and we don't want to wait for that. But if there would be some way to preserve the intelligence and creativity of people, of course, there are people that think, okay, let's store brains in computers. I think that's complete hogwash.
Why is that?
Uh, Why I think that's hogwash? Because we have no idea how brains actually work.
Right. That's a problem. That's a problem. Yeah, true. That's true.
That's a big thing. So you can say, well, I record the whole brain. Yeah, but what are you recording? The molecules,
Yeah.
or just the connections between the cells, or because so when you look at neural networks are an AI technology, and people say often, well, it's like a brain in a computer. It's inspired by brains, but it's no more than inspired by brains, because all the nodes in a neural network in a computer are very simple functions, and the brain cells that we have are very complex, with something like 50 different chemicals
Right.
which are
Yeah.
balanced in there. And there's another one. Our brains are massively parallel,
Right.
and
Right. Yeah.
computers tend to be mostly sequential.
Yeah. Yeah.
So there is no way that we're going to imitate that in a computer with the current technology and the current knowledge that we have. And I think it's much easier to create actually a kind of a brain in a computer that learns than it would be to copy someone's brain contents and put them in a computer. I think that's completely ridiculous.
Right. So, do you think there is a way to preserve these? Like, so if you could put Einstein, von Neumann, and all these people in one room and be like, "Yo, guys, can you figure this shit out for us?" Like, how would you like? Do you think there is any hope to that idea that you can preserve someone's
Yeah, but
cognition?
no, well, is there hope?
Yeah.
Yes, but not hope for us. We are not going to do that. But that is the speculation about such a far future that I don't think that will. I can not guess whether or not that is possible at all, or whether or not humanity has destroyed itself before we have reached that level that we could do
Right.
that.
Right.
Though I think there are possibilities to store more and leave more behind, but we need to build a lot more knowledge. We need to get a lot more knowledge about biology and
Right. Right.
chemistry and
Yeah.
etc. etc. But the thing that you say, well, if you have all these smart people and put them in a room, and then could we achieve things? And I think that the history has shown us that, yeah, if you have tough problems and you manage to put the right people in a room and say this is the problem that you work on, that they can come up with things.
Right.
We saw that, for instance, Second World War, the Manhattan Project, where you just put lots of very smart physicists in a room, and they very creatively solve some really hard problems, which progress science enormously and progress military science enormously. But that's maybe less happy occasion, but we get a lot from that.
That's true. Like, I'm thinking about like you know, so like if you think of uh, if you think of like reality as a simulation, right? Like
Yeah.
we need some people to figure out the hacks, like like what's like why can't we go faster than speed of light? Like what like can we break these rules somehow? Or like energy, like some of like the most fundamental things that we've like that clearly seem like unbreakable rules. Maybe there's a cheat code to the simulation.
Yeah. Okay. It's an interesting thought. Again, something that we will not get an answer to. But that's one of the things, if we loop this back to my interest in games,
Yeah, yeah.
one of the coolest things I think about games is simulating worlds. And I would love to work on a project where you try to simulate as big as possible a part of the world. And it doesn't need to be our world, it could be another kind of world where we have virtual creatures in that world that understand their own world, and understanding is something very nebulous,
Mm.
if I use that term. But currently, if you look at artificial intelligence or virtual creatures, that's usually rule based and things like that. It's not that they try to derive new information from observing their own environment. So, and that would be great if they could function on a level of a virtual character, of a human like virtual character in such a simulation of a world, which is at least on par with what a human that who implements such a virtual character would also be able to do. So maybe this is a bit fake, so let's give an example
Yeah,
here.
yeah, sure.
Suppose we have a virtual. So one thing that I imagine is, okay, the virtual world is just a small village, 5 houses, some people in there, and maybe, well, there's a mountain, there's a castle on the mountain. You cannot go to the castle, but the law of the land lives in the castle. But these people, they work on the land during the day. There's a baker and he bakes bread, etc. And people get their bread there, and they have basically their own little lives.
Hmm.
Um, and they survive because, well, someone goes on the land, gets some grain, brings it to the mill turns into flour, the flour brings it to the bakery, there's a cow there, they milk the cow, also the milk goes to the bakery makes bread, distributes the bread among the population, and this way everybody survives. Now the human comes in, there's a human player, and he comes in this little village, and he walks around and he observes what is happening, and he kills the baker.
Okay.
So what happens now? Will the villagers all die? Well, if they are rule based, they will die
Right.
because they cannot deal with that situation. The human did something, and maybe it's not that aggressive. Maybe he just locks the door to the bakery and throws away the key, and nobody can get in the bakery anymore.
Right.
But the human does something that interferes with their lives. What will these people in the village now do? And if they can analyze the situation, so they understand that there is a problem, first of all, that they cannot get any food anymore. That's not that hard to register because you don't get your bread and you expected bread. Can they understand what happened? Can they solve the problem? For instance, by letting someone else function as baker, do two jobs. Maybe the person who milks the cows is also going to be the baker and is going to bake the bread and distribute it. And maybe they lock the human player up in a jail so that he cannot interfere anymore. And or maybe they find a different. So maybe there's a lake somewhere and they start fishing for fish so that they can eat the fish. So if they can, and they should be able with an understanding do that almost immediately because
Well,
you have an
okay, okay.
understanding.
But to do that, they have to. I guess. Okay, okay. So this is where the general part comes in, right? It's like
Yes,
you have to
yes,
you have to,
yes,
you understand that, like, okay, so something happens, you can't get food, right? So it's like first you have to understand that you're dying, like as the thing. It's like, okay, and then you have to understand, why am I dying? And it's because I can't like, okay, the distinction here is, I'm dying not because I can't get into the bakery, I'm dying because I can't get food. It's more of a general understanding than just understanding the fact that I can't get
yes,
into the bakery. From Okay, so when you understand that I need food to survive, then you can from that generalize, okay, are there other ways of getting food that's just not the bakery, right?
yes,
Okay.
yes. And I think so. And I would love to work on something like that in a small world, and then you can expand that world because the further you expand that, the more steps you're making in the direction of an artificial general AI that works in our world.
Right, right.
And of course, that is in a long road that you have to go to get there, and you cannot go there immediately. So, okay, now we have basically a simulation of most of the world. We have our characters there which can respond to the world, and now we can just do this in the real world as well. There's still an enormous step that you have to make there, but it doesn't matter. You want to set small steps, and I know that at the moment we are not able to, well, in a very simple way, you're able to do what I just described, but there's a certain limit to the complexity that such a world can have.
Hmm.
And
Is that
uh,
computational limitations or?
No, it's mostly, so what I was just describing is a small village, and what is that village in this case that I described that really interested in is in they need food to survive, and that's it. I didn't describe any other problems for that little world. But you would have, these people would need complete lives. They need to have social lives. They need to, for instance, if I have another example that I sometimes use when I need to explain this is so understanding someone's behavior.
Hmm.
So you are sitting at a table in a restaurant and you eating, let's say you have fries on your plate, and someone comes in the restaurant and grabs some fries from your plate and eats them up. How do you respond? Well, that depends on who that person is. If it's a lover,
Yeah.
then you smile. If it is a good friend, you say, "Hey, you shouldn't do that." And if it's just someone you don't know, then you look, what is happening here? And if it's a bum, then you get angry. But that the response that you have depends on the social relation that you have with that person. So you interpret the same action in different ways depending on more knowledge of the world. So virtual characters need that kind of knowledge as well, and they need to be able to integrate it in their behaviors, and they need to be able, for instance, I come in as a human play in that world. I go into a house of
Hmm.
someone and steal stuff, and that someone comes and sees that the door is open because I left the door open. That should ring an alarm bell because that's not what they would expect to see. They locked the door before they went away, and now the door is open. So how are they going to respond to seeing that the door is open? How are they going to respond to seeing that the door is open and I'm standing next to the door, but outside? So and these kind of understandings means that you have to really, because the reactions normally when you look at how AI is implemented, they would program some reactions
Hmm.
in a game world. So they react to A, they react to B, they react to C. But there's a human player and they can do anything, and they don't know how to react to anything. But if they would have a certain understanding of the world that they live in, then they could come up with plausible reactions. And that is, I think, small steps toward artificial general intelligence.
In this situation, they'd have to learn about the environment that they, right?
Well, if you ask me, I think that machine learning, or generally learning, is the core of everything that is artificial intelligence. So there was a time that we say artificial intelligence, if you just program some rules in the computer, then we call that artificial intelligence. Nowadays, what you want these computers to do is so complex that they need to learn.
Hmm.
You must give them a data structure which they can fill in, and a method of learning. And you have to tell the computer what they should learn and how they should assess whether they have learned what they needed to learn. Because if you have these things like that data structure and a learning method and a method of assessing how good you currently are at what you were supposed to do, then you have machine learning, and then you can learn basically everything for which you have enough data supplied.
So you think we can learn our way to intelligence, like general intelligence?
Well, I think that general intelligence is such an enormously complex problem that if you think that you're going to create that without having machine learning, then that's ridiculous. But that
Yeah.
would everybody say. Nobody's going to sit behind a computer screen, not even a million people, million programmers, and all typing code. And at the end, we have artificial general intelligence. That's not going to happen. There's going to be fewer programmers, a lot fewer, and they are going to create a structure that teaches itself how to be intelligent.
Okay, so what is it? Okay, let's like okay. I think might be useful to like try and come up with a operational definition of what intelligence is, right? Because like
Yeah.
that's a pretty nebulous concept.
Well, yeah, yeah, sure. And I can tell you, I taught a course for a while which was called Understanding Intelligence, and I always started with, "I'm not going to tell you what understanding is. I'm not going to tell you what intelligence is because I don't know these things." We use them as terms to mean something, and in general, we know what we mean. But if you ask someone to really pin it down, that's really hard to do. And intelligence exists, for instance, in many different levels. A dog has intelligence,
Right,
but of course, not the kind of intelligence that we humans have. And a child has intelligence, but has mostly potential. And so, if you would define intelligence as the potential to learn new things, probably a child has more intelligence than an adult. But
right.
if you say, well, the practical intelligence that you currently have, then a child has a lot less practical intelligence than an
Yeah,
adult.
there seems to be this filter of like of useful intelligence, right? Like of being able to do stuff with the intelligence that you have.
I think that, for instance, the ability to learn is part of intelligence. The ability to make things more abstract so that you can see, I've solved problem A and I see problem B, and I see connections between these problems. So I can make an abstract of the solution for problem A and apply it to problem B. And that is a particular kind of intelligence, which we often call, what do we call this? Well, this is actually what an IQ test
Right.
tends to measure. So this kind of ability to abstract about particular uh, solutions, and not everybody can do that, but doesn't mean that people who can't do that equally well are less intelligent. And less intelligent, you have less intelligence of a particular kind, and probably more intelligence of another kind. Let's say business intelligence, understanding motivations of people and manipulate them. Well, it sounds a bit bad, but some people are really good at that, and you can say they have a very high level of intelligence to achieve certain things.
Hmm.
So I don't know if this is probably not an answer to your question. It was just
No, 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 no,
a
no,
lot of
no,
discussion, but
no. It's fine. It's fine. I was just no. It's like okay, no, because I'm thinking about like um there are like it seems I don't know if it's just my perception of the things that need to be done and that needs to be fixed, like in the world, like um but it feels like we are like the problems that we have to solve are getting more, and I mean 'cause, like we've like sort of we've taken care of a good number of the low hanging fruit, and the problems that we have to solve now are getting more and more complex, right?
yes,
Like how do we keep getting energy? How do we produce energy in a way that's sustainable? How do we um, like sustainable, but
yeah,
at the same time, like being able to have plentiful things to for human beings. How do we flourish while before we try to sort of combust into a ball of flames? Like it's interesting.
yeah, sure. No, yeah, and now you. So I don't think humanity will explode in a ball of flames,
Yeah, me
but the
neither. Me neither.
chance that
I'm on team human 100%. Like I think, yeah,
yeah, but the chance that things will be worse for humans in 50 years time than we have it now is there. There's also a chance that it will be better depending on how humanity develops and probably how much we invest in generating new knowledge and looking at the right problems, and how much willingness there is for people to sacrifice a couple of things for the future.
right. Yeah, yeah, true. Okay, let's. So intelligence is clearly valuable, but it's clearly also like hard to specify, and it's hard to generate.
And actually, I don't know if intelligence is valuable. I
Well,
just before
yeah,
said look. So this might be interesting. So
yeah,
um, I said, what you need if you want to create a computer that's intelligent, you have to give it enough data. You have to give it a way to store data. You have to give it an algorithm to learn, and you have to tell it. Uh, you have to give it a way to detect when it has learned something. So we call that usually an evaluation fitness or a fitness function.
right,
Um, The thing is that if you say, I want to make computers generally intelligent, then you need to create a fitness function that allows the computer to see how well it is on the way to becoming generally intelligent. So you must be able to say, okay, you do this measurement, and that means that you're more intelligent.
Hmm.
But what would that measurement be? And I don't know. I don't think I can define it. Uh, because what sometimes people say is intelligence is very worthwhile because it helps humans to survive. And you can actually see that that helps us to survive because humans are dominating the world. So we are much better at survival than all the animals that are there. That's because we are intelligent and therefore we can we can manage this. But then I say, look, a cockroach has survived for a lot longer time than a human, and when all the humans are dead, the cockroaches will still survive. But a cockroach is not as intelligent as a human. A cockroach solved the problem of survival in a much easier, much simpler, much more direct way than humans do.
Hmm.
And actually, the intelligence that we have might, because we, if you look at how we developed because of our intelligence in the last 2,000 years or last 10,000 years, is enormous speed up, but we're also enormously quickly destroying what we have. So maybe intelligence is actually a fluke. It's like these are dead genes, these are lethal genes. The fact that we have the genes to be intelligent means that we kill ourselves off, and that's it. So then intelligence is not valuable.
Hmm.
I think intelligence is valuable mostly because of what we can produce,
Right.
but I don't know if it's actually helpful for survival.
Hmm. Interesting. Yeah, like yeah. So even crocodiles, right? They've been around for 300 million years, something like that.
Yes.
So survival might not be okay. Less interesting. Huh? I didn't
Though
think about that.
probably if we want to survive, then we have to employ our intelligence. So we have invested in it. We are now, we created all this trouble for ourselves because we're intelligent, and now we have to use the same intelligence to get us out of that
Right.
hellhole again.
Right.
Well, it's not yet a hellhole, but it could become one.
But it also could be great, right? Like historically, we have solved a lot of problems. Like think
Oh,
we are okay. Historically speaking, okay, we are like if you had to live in any time in history, I feel like this would be the best time to live, right? Because it's way better than any time before that. Like just terms of like I mean, just like if you like the richest man, let's say Rockefeller, right? In
mhm.
whenever he was alive, he didn't have antibiotics. He didn't have anything. He like his son died. He was the richest man in the world. He couldn't save him from like a simple illness. Like things
Yeah.
have gotten. I think it's it's even if it might be a little naive. I don't know, but like it might be useful to think. Look, we can improve the situation that we're in. We can make new discoveries, solve these problems that we have, and come up with new ways of being.
Well, there's definitely many times in history, well, almost all of history, it's worse to live in that time than it is
Yeah.
to live now. Though I'm not 100% sure that there aren't any better times. If you talk about, well, you live longer, okay, we live longer than, let's say, 100 years ago, but are our lives happier? I think, yes, they are happier, but there's also, it varies from person to person. There are also people who find modern life incredibly stressful. Are
Hmm.
they happy? Would they have been happier 50 years ago? Maybe, yeah, you live 20 years less, but yeah, it's more quiet life and a bit easier.
Yeah.
So I can imagine that for some people, it would be better having lived 20 years ago, 50 years ago.
No,
Depends on also
yeah.
where you are in the world, probably.
Like I think what keeps me interested is that like I think we have interesting problems to solve. You know what I mean?
Yes.
There used to be a like I imagine there like if I had like I don't know. I find there's a distinction for me. Like there are distinctions that for me that in the sense that there are some problems that are just they're problems clearly, right? But they're not interesting to solve. Like we have interesting sort of problems to solve. It's like okay, this is really difficult, but it's like it's curious and interesting. Whereas like uh, I don't know. Maybe that's not a good. Maybe I mean that's just an instinct that I have, right? It's not like it's a empirical statement.
But though. to having the problems that you can solve, does that make life interesting for you?
Yeah.
Okay, yeah,
That's
yeah, I can imagine.
that's definitely what it is.
Sure, and there are definitely a lot of problems. Well, I think there are a lot of problems interesting to solve, but also there are many problems, and these are usually the more urgent problems that we have to solve, even if you wouldn't consider them very interesting.
Yeah, 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 yeah. No, no, for sure. Like, okay, look, like someone like someone coming all the time and taking care of my trash is hugely important, right? Like, it's super important. Like my life, like so many things that like I have the luxury to work on these interesting problems because a lot of those things are taken care of. Like like
Yes.
there's electricity to do this podcast, right? There's like food in my fridge. Like all these things are interesting in their own right, right? Of course. Like but
Yeah,
yeah.
so one thing that people that you probably don't realize, or maybe you do realize, but having access to the internet to do research.
Oh yeah, for sure.
This is such an incredible speed up. I
I
wrote
know,
my
I know.
master thesis in 1996, and well, I had to find relevant literature. So I had to go to a library, and then you might be happy that you're in a city with a library. And then I had to, okay, I need to have this journal, I need this journal, and somebody brings them to me, and I make copies of them, and then I hand them back, and I need this journal and this journal, just and so I was for 2 days in that library just copying papers, and I had a stack of half a meter high of copied papers, and those I took home and started studying. And most of those papers I could throw away; I didn't need them. But yeah, there was no really a good search. And after that, basically, that was all the literature research that I did for my thesis. While later on, I found out that other people also did work in that area, but I hadn't been able to find them because there was no internet. How am I supposed to find these things?
Yeah,
And
okay.
nowadays, it's all there at your fingertips. And
Okay.
also, that's a bit intimidating. But
Okay, this is interesting. This is interesting. So this is an interesting topic I want to talk about. Okay. So the internet, right? Clearly the internet makes me a smarter person, right? I mean,
if you use it
if
well,
you use
yeah,
it well, right?
it can also make you a more stupid person.
Yeah, yeah, true, true, true. So like think about like this is like this just blows my mind, right? Okay. So I had within in the span of like maybe 6 hours. No, maybe not 6 hours. Maybe like 10 hours, right? In the span of 10 hours, I trained a computer to recognize pictures of birds, right? So
Yes,
like 2 lines of code, right?
yes,
Whatever, right? And then I took that model, I put it in a I put it in a put it in a self-contained little machine that people from anywhere in the world can access and talk to and send stuff to.
yes,
Then I put that thing on the internet, and now anyone from anywhere can just go to www dot something 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 forward slash, go to the API, upload or whatever they want, and get a prediction back immediately. Right?
yes,
I did that just like in one sitting. Right?
yes,
That's like, but if if you had told me that to do something like that without the internet, I'd be like, "What are you talking about? Like, I have no idea. I don't even know what you mean,
uh,
right? Like, but the internet, because like, so I went the internet. I got a bit from here. I got a bit from here. I got a bit from here. I was like, okay, cool, that's nice. That'll work. That'll work. No, that doesn't work.
yes,
And then I get an error. Then I search what the error means, and then I put them together and like duct tape it and like and it works, right?
yes.
So,
But this is actually the, say, the mantra of the early computer scientists, the people who worked earliest with the computers. That was, they were rather socialistic, communistic, or whatever you would call it. So code should be free. Everybody should have access to all the code, and we're gonna create code and we share it, and then we build on top of each other's code, and then we make things much better. And that is actually how most developments in computer science are done, and that is also how the internet is built and how you are now using things, because people just give you stuff and you use it. And the funny thing is, of course, that those people who did that could have been really rich if they would have been more businesslike. But they were not interested in that, because that was also Bill Gates. That is how Bill Gates became really rich, because initially he was really angry that people started using his code because he created a basic compiler and basically was working on that. And he had an old version of the basic compiler and he threw it out in a bin, and somebody took it out and made something else out of that.
Right.
And then Bill Gates got really angry because that is, I own that. And basically that attitude made Microsoft.
Hmm.
So, but that's proprietary code. But that's not how the world, in computer science at least, gets better.
So what about this idea of like, okay, so one person is really smart, but 10 really smart people together can accomplish something
Yeah.
like that they couldn't do alone, right? So this
Yes.
uh, is it possible that maybe like the internet will turn into the AGI? Like it'll something
No, no,
something
that's what that's a bit of a
science
no.
fiction-y
So
situation.
no, it sounds. So this argument I've heard quite a bit. The idea is okay, and that comes from people like Ray Kurzweil,
Okay.
who then says, look, uh, we have Moore's law, which is not actually law, it's an observation, but it has held up for a long time. That means that every year and a half or so, memory capacity of a computer doubles, speed of computer doubles, storage space of computer doubles. So everything that is important in a computer, number of circuits on a chip doubles every year and a half or so. And if you then say, okay, then if you look at where this is going, that means that capacity of a human brain in a computer we will have by 2030, and by 2035 or 2040, we will have the capacity of all the human beings together in one computer. And but that basically means that now we have computers that can do the same things as humans. That is then, or you can store a human brain in a computer, and that's basically the religion of computer scientists uh,
Right.
who believe in that. So, religion is about life after death,
Yeah,
usually.
yeah, yeah.
And okay, I can survive after that because I store myself in a computer, which sounds a lot of fun, but it's just a religion because there's no way that we can do that.
Right.
Um, but the mistake that is made with this line of reasoning, just to spell it out, because maybe you already see what the mistake is, but the mistake is that it's only talking about hardware, and intelligence is software.
Right.
And you need to have the software, and just having the capacity to store a human brain doesn't mean that you can actually store a working human brain. You have to create a software that does that, and if you don't know how a brain works, how are you going to create that software?
So what about the trajectory of just sheer compute, right? Like how are we looking in terms of like like where do you see that going in terms like so there's like okay just let's talk about machine learning, right? There are many different algorithms and ways to do machine learning. Do
Hmm.
you think there's still room to be gained by new ways of new algorithms of doing stuff?
Oh, I am convinced of that. There is almost all the machine learning nowadays, and so almost all the artificial intelligence research nowadays, or almost all, let's say 90% of it, is invested in deep learning.
Hmm.
New technology came up in 2014. Actually, it was an old technology, but because of the enormous increase in data and the enormous increases in capacity that computers have to process things and in speed, the old technologies could now be used to analyze all that data and produce new results, and surprising new results. So the technology actually worked a lot better than people could have predicted.
Hmm.
But the technology is purely on pattern matching, so finding patterns in data and use that data. And I think there are many problems that are not pattern matching problems. But since there is so much low hanging fruit that you can approach with deep learning technology, that means that people are now investing a lot of this research in deep learning technology to get that low hanging fruit out. But when I look at what deep learning technology or the deep learning research often entails is, okay, I got this big data set. I'm going to build a deep neural network that does something with that data set. And most of my research is tweaking the number of layers, tweaking the hyperparameters of the network, and then run it again and again and again and again and again. And then at some point, I have found something. And there's almost, well, there is probably some knowledge behind how you're going to tweak those hyperparameters, but there's so much tweaking to do. And a lot of this is just, oh, I'll try it out. And I try it out again, and I try it out again, and see if I get something better.
Mm.
And I think there an enormous limitation on things that you can do. So one limitation that is in games, I also like games because there's such a wide variety of problems that you can define in game terms. So I play lots of different kinds of games. One type of games that I play is tabletop role-playing games. So people sitting at the table doing collaborative storytelling, where you have a bunch of complex rules, but mostly it's in the hand of one player. It's often called the dungeon master or the game master. He knows the background of the story, he knows the world, he knows the people that are in the world. And when a player says, okay, I'm running a particular character, I'm going to interact, I'm going into a bar, I'm going to interact with the people in the bar, then the game master is going to play all those people because he knows or she knows the story that is going to be told,
Mhm.
or at least knows the ingredients of the story, and has to respond in an acceptable way towards what the players are doing. And for instance, what you need to know, because I am often the game master, need to know the motivations of all the important characters in play. Because if you know their motivations, anything that the player can do, you can at least find a response to, and a quick response to. Creating a computer that functions as a game master. You're not going to do that with deep learning.
That's huh. Why not?
How would you do it? Because you have to have an understanding of that world. And as I just said, what the only thing that deep learning and deep neural networks do is pattern matching, and pattern matching are not understanding.
But can't you learn the like? So if you had enough if you had enough recordings of, let's say, play sessions, couldn't you learn the to mimic the behavior of?
No, no, that's interesting, and yes, sure. I think that would be if you ask someone who's specializing in deep learning how to do it. Says, look, what game are you talking about? So I have a game here which I have run a couple of times now. It's called Curse of Strahd. It's a Dungeons and Dragons game and plays in a world, small world, which is ruled over by a vampire lord, and there are lots of intrigue going on there. And what you can do is, if you have recordings of all the play sessions that people have done, because maybe thousands and thousands of people have run this game, and you have recordings of all those play sessions, and you have recordings of discussions of this game on the internet, and you have maybe Twitter feeds that are talking about this game, and maybe you have visual recordings of the game, and
Mm.
you have the game book, and so you can bring all this data, and then maybe using deep learning technology, you can get a sort of a dungeon master or a game master who can run this game to a certain extent. Probably not completely, because you probably need much more data for that. I mean, I said thousands and thousands of games have been played, but thousands and thousands is not enough to train on, because there's such a high variety that you can get
Mhm.
that is very hard to see what is the same between the games. And people adapt that game to their own needs. You have to do that. So it's more okay. Maybe if I try to shortcut it, it's about how much creativity you need.
Right.
And you can say, well, with deep learning, you can do creativity. So you can, for instance, generate images,
Hmm.
but they are not new images. They are recombinations of images that already exist. And it can be really interesting. And with a lot of tweaking, you can get really interesting images out of there. So you can, as an artist, you can generate things which are what you need.
Hmm.
But the artist is the one making the ultimate selection here. So there's not. So you have things like DALI and Stable Diffusion, and you type a sentence in and you get an image that represents that sentence. But usually that first image is not a good image. It's not what you wanted, and you have to start tweaking the sentence and tweaking the image, etc. And after a while, 50 iterations or something like that, you might have the image that you want. But those 50 iterations, that is where the intelligence and the creativity comes in, not in the generation of that image.
Right. Okay, so how did they how did
So,
how did they how did they manage? So the only thing that comes close to my mind as opposed to a scenario close to a scenario what you might have just said is like is Dota, right?
mhm.
So when they did the Dota play, they made it. I mean, the OpenAI managed to beat the top team at the time with the
The open, I don't. Yeah, it might be. You are interested in Dota. I'm
yeah. No,
less interested in Dota, but I
so
don't know exactly what that was. But yeah, but first of all, you have a lot of data
right.
for something like
Yeah,
Dota. There are so many recorded games.
also they generated like I don't know how many hours of gameplay for the
Yes, so
GDR.
you have all this data that you can feed it with. The games are pretty much the same. It's not that you use the same tactics and strategies, but it's always the same goal and the same targets that you have, and
Yeah,
so you can learn a lot about that particular game. But suppose so, if I compare this with StarCraft 2, for instance,
yeah.
where DeepMind made AlphaStar,
Mm,
and AlphaStar defeated really strong players. But if you look at the paper that he wrote about that, what it actually does, it beats really strong players uh, on a particular map, on a particular version of the engine.
mm-hmm.
And it's even the case that they had different versions of the AI. So the strong players, and they played 5 times or something like that against the AI, but they 5 times they got a different AI and not the same AI. So you couldn't actually try to predict what the AI was going to do because it was a different AI all the time.
Right.
So they cheated a bit in that respect.
Yeah,
And
even the Dora team that lost, they were like, if we played 7 games, I think we probably start taking like they probably get the first few, but then after we played them a few times, I think we'd have we know how to beat them.
yeah, so what these AIs do at the moment, at least, and that probably the generalization will be coming. And I know that Alpha Star also had a version that was a bit more generalized, but usually they are overfitting, so they are all on the particular features of the game. So they have one map and one engine with a particular set of characters, and those they can do really well. And then they have the advantage of that there is a computer controlling these characters, and the computer uh, has faster reactions than humans. Will not need to take back moves.
Hmm.
So this one thing, we also did some research in StarCraft at some point, and we looked at human players and what distinguishes a really strong human players from few less strong human players and less strong human players, etc. And we found that the big difference was the keyboard interaction, in a particular taking back actions, so undoing actions. You do something and you do something else again before the action was executed. Really strong players don't need to do that. What they type in the keyboard is what's going to happen.
Hmm.
And computers, of course, can be excellent at that particular aspect.
So like, but there's clearly a lot of investment and money going into to beating these games, right? What's the rationale here?
Uh, okay. So there are probably lots of different rationales. First of all, I said games. If you try to do something, let's say you want to create an artificial intelligence that wants to do that does autonomous driving.
Mm,
So you can just sit behind the wheel, fall asleep, and the car will bring you where you want to be. So the ultimate level of autonomous driving that has been promised by Tesla since 2014, that it will be there next year, and it's not there, and it will not be there because this problem is far too hard to solve. So if we can solve that, that will be 20, 30 years in the
no, but
future. And
what
but
what do they have now? Like they have autopilot now, right? I don't know enough about it.
no, so you have different. Okay, well, there's another topic. So maybe
Okay,
I will first make the argument for the
sure.
game, because if you want to do this
Yeah.
and you want to do this and you try to do this, let's say in Grand Theft Auto,
Hmm.
and you don't succeed to do this in Grand Theft Auto, what chance do you have to do this in the real world?
Mm.
So the idea is that the game is a similar challenge that you want to solve in the real world, but a lot easier. And that is the first step that you take. And that is why people often look at games to do their first experiments, because it's a nice demonstration. They can show, okay, we can do it here, and now maybe we can go further with it. And as I said, nice demonstration. Also, you can show the quality by comparing, for instance, with humans. Now, if I go to your the car example, because yeah, I threw that just in there. But if you look at the people who study autonomous driving in cars and that work on it, they have 6 levels of autonomous driving, which are distinguished. Now, level zero is no autonomous driving at all,
Hmm.
and then level one is maybe automatic parking. I don't know exactly. Level three is, um, I think, level three is that you can do some automatic driving, but the human basically must sit behind the wheel, keep the hands on the wheel, keep the foot on the pedals, because you might have to brake quickly, because the computer makes lots of mistakes. And we are at that level now, so you cannot let the computer go by itself. Level four is that you can drive on the freeway,
Hmm.
which is probably achievable. Level five is that level where you say, okay, tell the car I need to go there. Just find your way. Make sure I'm there at this time, and you can just sit in the back and watch a movie or something like that, and the car will bring you where you need to go, wherever it is. Now, there is such a huge leap from level four to level five.
Hmm.
That and level five is what being promised, and I'm pretty sure that Tesla will at some point tell us that they have achieved full autonomous driving, but then they just have redefined what full autonomous driving is.
Hmm.
Because that is, yeah, you have to do something.
But I still think it's cool to have like companies around to try to do this kind of stuff, right? That's pretty interesting.
No, actually, I think, for instance, full autonomous driving is probably possible, but you also have to adapt the cities. So
Mm.
if the cities have lots of the sensor apparatus, and that measure what is happening, can send signals to cars, and all the cars are fully automated, then you can do it. Because then there is no doubt anymore. The cars just need to respond to each other, but cars that need to respond to dynamic situations which you have never seen before, and not make big mistakes, because humans also make mistakes, of course, in the car, but they usually recognize the situation and can respond usually in the
So
right
this
way.
seems like a you have to solve intelligence sort of first before you get the situation.
I think it's if you want to have the full autonomous driving, you have to do almost complete artificial general intelligence to do that. Although I might be mistaken in that, just like the people who thought that if we could play chess, we have artificial general intelligence, and then we had chess players and as a computer, and then of course there is no artificial intelligence in there almost at all.
What are some promising? Do you have any like off the top of your head like promising areas that you think AI, even the narrow applications we have right now, like have good potential to like really make a dent in the next 5 to 10 years?
Yeah, I find it very hard to answer those questions. I can talk about the next 5 years,
Yeah, sure.
because usually when what happens in the next 5 years are the things that we can already do,
Hmm.
but which, uh, well, they maybe you need a little bit more speed, or a little bit more precision, or it must become a little bit cheaper to do, and then it will become
Right,
more
right.
common. But if you already start talking about 10 years,
It's
then it's
hard.
things that we don't know exactly how to solve right now.
Yeah.
And then you might hope that maybe we do A or B or C, and then we can solve it, but we can't do it. Typical example is, I've been thinking about this quite a bit, is quantum computing.
Hmm.
So quantum computing is a big hype, and I'm thinking, why is this such a big hype? Why is there so much money invested in it? And that is because of the potential. So if you can do quantum computing, then there's a potential to do things that we cannot do right now, like cracking certain codes,
Hmm.
which are too hard to crack with the computers that we have now. But quantum computers could do it. But quantum computers generally, they exist in theory, and there are certain physics problems that need to be solved before we can have actually working quantum computers. So you can show, look, yeah, this is possible, but it will only work. This quantum computer exists for a couple of nanoseconds, and then it's gone again because then it's entangled with the environment and it doesn't work anymore. Um, but there is enormous potential. If you can solve this, there's enormous potential. But I don't know when they will have solved that.
Right, right.
So when you see that people study quantum computing and do quantum computing research, then I think a little bit, is that too early? Because you don't even know if a quantum computer will ever be created. Maybe it will never be there because there have been so many attempts and nobody has ever created one. And it might be that, of course, once a quantum computer, so we have, for instance, Shor's algorithm, which can do that, finding the prime factors of numbers,
Hmm.
which is an algorithm that has been defined for quantum computers. And once we have a quantum computer, we can now do this because we have this algorithm.
Right,
So we just load the algorithm in the computer and it's done.
right.
So then it shows it's valuable research. Until that time, it's okay. Yeah, it's nice to show that it can have value, but it doesn't really have value yet. And I wouldn't dare to say anything about when a real quantum computer would exist that would actually be usable for anything.
Right. Well,
Yeah.
that's well, uh, that's okay.
That's not AI.
No,
Although
no, I
people
know, I
talk
know, I
about
know. No, it's cool.
people talk about quantum AI, and I think
Yeah,
that, I mean,
yeah,
what is that? I have no idea.
yeah. Well, Dr. Sprong, I want to be respectful of your time, and
Oh no, it's
yeah,
fine. It's fine. I have 20 more minutes or so if you want
yeah,
to.
yeah,
But
yeah.
if you're done, that's also
No,
fine.
no, it's fine. It's fine. No, I know. Yeah, I know. You said you gotta go make dinner. So, um,
Sure, but I bought stuff that is very quick to prepare.
but okay, but I do want to ask like like the one like I don't know like so you've been in academia for a long time, right?
No, actually, not that long. I've been in academia for 22 years now.
That's a long time for me. Like
Yeah, for
what?
you maybe it's a long time, but considering my age, I spent 15 years in the industry before I went into
Right, right,
into
right, right.
academia. Yeah,
So you
so I've seen both sides.
right. So what do you have any advice for, let's say, someone like, well, me, but also like people who are just trying to, I don't know, like thinking about masters or like graduate school, academia versus industry, like how do you navigate this space? Any advice?
Okay, so anybody who is in a topic like computer science or artificial intelligence, or no, artificial is logical, but I think getting any topic that you're studying, getting some courses in artificial intelligence, at least one course in artificial intelligence, and a course in programming.
Hmm.
Um, these two, I think, are important for almost everybody because whatever you are gonna do uh, as a job, you will find that your work is changing because of computers, which you need to understand. And the understanding of computers you learn when you learn programming. You need to have that kind of thinking, which you use when you try to program. And artificial intelligence will change your job. I don't know about any jobs that are not changed by artificial intelligence. So a while ago, I'm talking about maybe 20 years ago, somebody asked me, she was a hairdresser, and she asked, will my job be taken over by a computer? And said, no, not hairdressing. And now I think that's one of the easiest things there is, hairdressing by a computer. I mean, we do medical operations with a computer and medical stuff, and let computers do surgical things. And hairdressing. I mean, what can go wrong? Yeah, probably a lot, but it's it's only first world problems.
Right.
And so no, that is. So I don't know. So if you're a visual artist, the AI techniques to create visuals are there now, and they are usable, and they will get a lot more usable in the very near future. So the tools are still a bit rudimentary, but there will be tools for everything. If you are working in the movie industry, let's say, control of the camera that will be taken over by artificial intelligence. So somebody just tells the camera, this is what you should record, and the camera will doing it. So artificial intelligence will be everywhere. It's usually just question of how much money needs to be invested. Jobs that are still safe is maybe author, but if you invest in being an author
Hmm.
of actually novels, not of newspapers, because that is going out as well. But if you that's not a job where you can earn a lot of money anyway. But artificial intelligence is crucial to developments in technology, and technology is crucial for anything that you can do.
So what about some specific advice for someone like me who is studying artificial intelligence and like who is going into doing a master's in an academia
Well,
probably?
my general advice would, first of all, your master thesis is not determining the kind of job that you're going to do afterwards. So people often ask me if I do this. So I often have master thesis topics which are in games, and then they say, "Look, should I do this because I want to work in business later? And if I've done something for my master thesis with games, that doesn't matter. They don't look at what your master thesis topic was about. It's that you have this knowledge, that you know about artificial intelligence, that you know about computers, that you know about data science. That is your education, and that you did a master thesis. Nobody cares about that. So that is one thing. So
That's good to know.
do something that you find stimulating. Um, and of course, you cannot, you have some restrictions there, so it's always in talk talk to someone who does research that you think, this is interesting research, I would like to do something in that direction. Talk to the person, and if they say, yeah, well, I can define a nice topic for you, or we together, or maybe, often I always tell students, what do you want to do? If you can come up with a topic, they say, this is what really stimulates me, and I think, okay, that could be a thesis, then I'm I welcome to do it, and I will supervise it. That's fine. So that is definitely helpful. For the rest, so with job perspectives, just finish your studies. If you want to do, if you want to do a PhD,
Yeah.
so but that's just a very small select group, then it also makes sense to be a bit more selective about what you do,
Hmm.
because the grade that you get for your master thesis will be usually taken into account by people who want to hire you for a PhD position.
Right.
So, so then make sure that you not only ask, okay, is this a master thesis, but also, does this have the potential to do, for instance, to lead to a publication? Because that usually, if you can create a master thesis that also is published, or a paper of it is published in a journal, or in a at a good conference, then you will also have a good grade, and you will have your first step in the further stages of academia.
Nice. All right, great. That's
We
that was.
yeah, we didn't talk a lot about games
Oh
actually.
yeah,
So
yeah,
I
sorry. We
thought,
got so distracted. Like I got so distracted about the intelligence stuff. Like we'll definitely have to
yeah,
do this again sometime. Talk about games
sure,
because like
sure.
I had so many
If
things to ask you, but I was just I got completely distracted.
yeah, okay. Now, welcome to do it once more
Yeah,
if
for
you
sure.
can come up with another topic.
Yeah,
So
yeah, for sure.
we can do this again.
Again, thank you so much for joining today. I really appreciate it. And like, obviously, it's always fun to talk to you. So like, we instead of us talking randomly during the TA hours, I thought we'd just sit down and just talk about this stuff. It'd be fun. Uh,
Yeah, well, and usually there we have to be silent, or students can interrupt us.
yeah, yeah, true, true, true. All right, cool.
But I hope that you can hang around for quite a while longer. So don't finish too quickly
Yeah,
again,
yeah,
right?
yeah. For sure. All right, all right.
Okay.
Okay, so thanks, Professor, and yeah, I'll see you.
Thank you.
I'll see you in class, I guess.
Was fun.
Yeah.
See you.
Bye.
Bye bye.
That was an awesome conversation. Thank you again for joining me today. I hope you enjoyed it. Hope you learned something, and I'll catch you on the next one. Bye.